Alrighty, let's get started then. You guys checked in already? Good to go with the QR code? Leave it up there for another second or two. I'm good. Cool. Alright, I'm feeling a little off today. Didn't get too much sleep, so if stuff's unclear or anything like that, just holler, or if you need me to speak up or anything like that. Today's focus is going to be on features, so turning our 2D sketches that we talked about last week into 3D parts. We'll go through most of the different features. There's a couple more advanced ones that we won't touch until later. But there's also a couple things that I came up with that I guess I missed covering last week in sketching, so I figured I'd cover that here real quickly. So let's go ahead and pop into SolidWorks. Properties. Window. SolidWorks. There we go. All right. So there's two things that I wanted to talk about really quickly. Just open up a new part to get started. The first one I covered in my live stream, so if you guys caught that, you should know about it. It's basically dimensioning off of a center line. So if I start a new sketch, and we talked about center lines, they're basically just construction lines anytime you place one down. And then let's say that, kind of with our cup example, I have the side wall of my cup there. And I want to dimension this diameter here. I'm going to click on the point in this line, and then I get my radius dimension. But again, kind of SolidWorks can treat any construction line as a center line, and as I drag this over, you can see that it turns into basically a diameter dimension if I were to revolve it around that center line. So again, kind of from here over, and let's say this is like a 60 millimeter diameter cup. Then you can see it on my cursor right now. There's a new icon. There's the dimension, there's a D, and there's a little dashed line right next to it. It's basically telling me that it's doing a diameter dimension around that same center line that I selected. So I click on this point right now, it automatically wants to drop in a diameter dimension. If I want to exit out and just do a normal dimension, it still keeps my point selected. Then I can go back to that radius, and then I can also go back to diameter as well. Same thing goes for angles. If I want to, I just clicked on that line, saw that I didn't even click on the center point. It automatically was like, hey, I'm dimensioning off of this construction line. I'll keep plopping in dimensions off of that. So maybe the draft angle on the side of this cup is 10 degrees. And then you can see that now the D right next to my cursor changed into an A. So it's angle dimension off of that center line. And again, to exit out, I just press the escape button, and that the A and the construction line drop off. So now it's just back to normal dimensions. So that's a pretty cool little trick if you're doing a lot of revolved or symmetrical parts around a center line. It's a really neat way to speed up your design process for those. The other thing that I wanted to touch on is this Instant 2D button up here. It basically lets you modify stuff in your sketches. By default, it's going to be kind of turned on. And then, I just click. Basically what happens is, in this Instant 2D, exit out, there we go. Anytime I click on dimension value, it's automatically going to want me to try and adjust that dimension. I usually just turn this off, just so that anytime I click on it, it just brings up all my dimension properties. Or, if I want to delete that dimension, I don't have to, with Instant 2D on, I actually have to click here to bring that up, versus on the dimension value. If I'm super scrolled out or my dimensions are pretty small, it's kind of hard to grab those handles sometimes. So I recommend turning that off. It is kind of handy sometimes, but for the most part, if I need to edit this dimension, I can just double click to bring up that value. Or if I just want to delete it, I single click, right? So those are the two things that I had kind of left over from last week that I didn't get to cover. But we're going to move on to features. So the most basic one, let's just start with some basic geometry here. We'll make a rectangle, dimension it out, maybe 100 millimeters by 60. Cool. Fully defined sketch, so I'm good there. Exit out of my sketch, and now we'll kind of look at the features toolbar. So this extruded boss base command is it's the most basic of the commands. It takes your profile and keeps a constant profile extruding upwards. See, there's this little arrow here in the middle. You can kind of drag that up, and it snaps to millimeter increments here. So you can kind of visually, if you're just trying to get like a conceptual understanding of roughly how big this part should look or something like that, this is a great way to kind of drag it and be like, okay, yeah, maybe there. And then you can also, there's another arrow down below, brings in another dimension that you can go. So you can drag, or you can extrude in 2 dimensions. See that here is direction 1, direction 2. We'll talk about just direction 1 for now. So right now, we'll go back to there. This blind, this is your default basically, and it means that you're just giving it a value of how far to extrude. So in this case, you kind of drag that handle around. It's trying to extrude 70 millimeters. If you kind of, we'll kind of talk about the other features with that later. But blind, just basically you punch in a value, it extrudes that far, gives you that constant cross section all the way up. And then the next one, up to vertex. If you have another part somewhere or another kind of edge or vertex, you can click on that vertex and it'll figure out that distance from your sketch up to that point. Same thing with up to surface. And offset from surface, we'll have to create a couple of features for us to kind of explore these. And then the other key one that's really nice is this midplane. So it takes your sketch there, and if you remember, we centered our rectangle on the origin. This way, if I were to extrude this out in the midplane, the origin's at the middle of the part, which is sometimes handy if you want to keep kind of your CG just approximation at your origin. Or if you want to kind of make your part symmetrical around all the 3 default planes, that's a good way to do it. Just use your midplane, and it makes this edge here that we're extruding 70 millimeters. So it's basically doing 35 up and 35 down. But again, we can kind of do 2 directions at the same time. So in this case, 70 millimeters up and let's say 30 millimeters down. Looks something like that. You can kind of see the difference between going up and down. And then here we have the same features or same options: up to vertex, up to surface, offset from surface, and up to body that we did have here. We don't have a midplane option here because midplane gets rid of this direction too. And then we also have this thin feature option, which I will cover in a little bit. We're just going to talk about selected contours first. So in this case, if you have like a complex sketch with a lot of different contours, a lot of different shapes, you guys remember the steering wheel that I talked about in the first session, I can just pick out just the individual parts of my sketch that I want to extrude. So just to give an example of that, edit my sketch. I'll plop in a circle here at the origin too. Maybe give that circle a dimension of, let's do 45 millimeters, just for funsies. All right, so now when I go to extrude the sketch, or another little tip here is if you draw like, a couple of sketches, you want to go and extrude your sketch, you can do, just click on extruded box base, and then out here you can click on your sketch, or you can pre-select. Pre-selecting is usually a little faster because your feature tree is already here. Just click on the sketch you want to extrude, or within your kind of viewfinder here, you can click on that and click on extrude, and it's going to bring that up. And if you look, it's trying to extrude that whole rectangle. If I just want to extrude, it'll if I clear that out, it'll kind of show me the preview for just this section here. Maybe I just want to extrude the circle this time, and I want to do it 15 millimeters up. And then what I want to do with the rest of it, you can see my sketch disappeared there. Go back to my feature tree, click on that. And what I want to do now is instead I want to do a mid-plane extrusion here for 10 millimeters. And so I can reuse that sketch for 2 different features, and I can pick out which part of that sketch I want to use for my extrusion here. You can kind of see there's this is on our top plane going up, and then this little rectangular feature is centered around our top plane. Maybe I'll bring this up just to kind of illustrate that a little better. So that's kind of what we're looking at. Cool. So let's make some other geometry on here just for fun too. So go on the front plane. If you remember talking about designing cups or something similar, should probably make this I'll go ahead and just sketch it in. So we're going to start sketching in, kind of build that relation off of the midpoint of that part geometry. If you remember last week, we talked about how we don't actually have to bring in the geometry. We can just use the other geometry out there and start our relations off of it. make my cup shape. Going to make this a center line or a construction geometry basically. Make use of those dimensions. So if you remember, our bottom dimension there was 45. Probably want this top to be 60 millimeter diameter. I'm going to make this 40. Make the height of my cup 50. And then again, I got that fully defined sketch. So from here, I'm all done. Another little tip, as you're going from sketch to feature, you don't actually have to exit your sketch up here. You can go right to the features tab and click on the feature that you want to start making from this sketch. It's kind of, again, speeding up that time, pre-selecting your sketch. You're just doing it because you already have the sketch open. So I'm going to click Revolve. It's going to give me this message here, which you won't see in the stream, unfortunately, but it says sketch is currently open. A non-thin revolution feature requires a closed sketch. Would you like the sketch to be automatically closed? So it's basically telling me that I don't have a closed section of geometry, so a watertight path of non-construction lines in my sketch, and it wants to close it for me. And what it's basically going to do is draw another line in the sketch on top of this construction line that is a solid line. So I can just click yes, and you can see that because I only had that one construction line, it's like, all right, that's probably the line that we want to revolve around. So I'm just going to use that, go around that way, and here's my options for my revolve. So kind of similar: blind, up to vertex, up to surface, offset, mid-plane. Blind, by default, it goes 360 degrees. If I only wanted to make half of this, for example, I do 180. And you can see it starts to go that way. I can switch the direction that it revolves. And I guess maybe a better one would be like 90 degrees. See, it's starting from the plane, going that way, and you can also see the arrow there. Same thing with the arrow. You can drag it around to get a feel for how much you're extruding or revolving. And then mid-plane, same thing, just goes both directions there. If I don't do mid-plane, I do also have the option to do two directions there. So I do have all those options available to me, just like with the extrude. In this case, instead of extruding along an axis, we're revolving the profile around the axis instead. So then 360 degrees. And then there's this other checkbox here, merge result. So with any of our features, as we start building feature on top of feature on top of feature, this one's going to create a solid body, and what it's asking me is if I want to merge this solid body with the rest of my part to make just one body, basically. If I don't merge the result, I'll just kind of do this as an example. Again, those options for selecting contours are here too. So we're not going to merge the result. Over here in my feature tree, we're going to see that we have two solid bodies. If I can expand that out, there's my first, and there's my second. So you can see that by revolving that, it's its own basically standalone part in the model. It's not merged in. We're not creating just one big part with all this complex geometry. We've actually created two of them within the same part file. So this is top-down modeling, if you remember back to our first lesson. I can always go back and change that. So if I edit this feature, right-clicking on the feature tree there, clicking on the edit feature button, I can click that merge result. Now I only have one solid body, so this is all treated all together. And that's what we're looking at. Go ahead and hide this plane here. So the revolve and extruded features are super simple, very easy to use. Just require a closed profile, and in the case of the extrude, going in one direction, just have to, it's normal to the plane that you sketched on. And then for the revolve, we need to select a axis that we're rotating around. So let's go back and modify this real quick. So I can show you here. So by opening up that sketch, you can see that we created this line, or SolidWorks automatically went in and made this line for me. If I delete it, we can kind of bring back that construction line that's right behind it. Kind of brings up something that's important. If you can't select the thing that you want to select, because in this case they're right on top of each other, you can right click and you have the option to select other right there. And then you have, here's your line 1 and then your line 6. So line 1, you can see in orange, It's going to be that dashed line, the construction line that we wanted to click. So I'm going to go ahead and remove that from the sketch because it's redundant. And bring up this little error message. Item has associated dimensions. So that 50 millimeter dimension is defining that line. So it's just giving me a warning. Actually, it has a lot more than just that one. So all those diameter dimensions were off of that too. So go ahead and just re-add those in. And you can see that as I click on this non-construction line, it doesn't let me drag over and make that, make it basically a diameter dimension. So that's kind of your trade-off there with using construction lines and not using them for these features. But let's see, what did I want to do? Oh yeah, I wanted to make this cup a hollow cup. So instead of actually closing off the top of this, we can make it hollow. And actually, I'll just make the wall itself. So we'll bring in some ideas from, or some sketch tools from last class. So we'll go offset entities, take that one in. We'll make this a 3 millimeter thick cup. And then I don't want to cap the ends because if I do, you can see here, I'll use the lines. It's making this little gap down here. I want to not have that gap if possible. So I'm not going to cap the ends. Just going to offset that line inwards by the 3 millimeters, and I'm going to add dimension to it as well. And then let's see. Oh yeah, I need to do that there. Make those two horizontal to each other so that this 50 millimeters controls that point. All right, and then I'm going to add in some lines. All that matters is that they're horizontal. Down here, I'm going to extend this line down. And then I'm going to trim some stuff away. Power trim that away, that guy, and that guy. So now you can see it's shaded in. And I still have my center line here. Exit out of the sketch. And because I had already created that feature, SolidWorks is going to rebuild it. Just going to take that new sketch geometry with the same line, because I didn't change the line, and just go ahead and try to rebuild that revolve. And now we have a hollow cup. So you can kind of see that after I create my feature, I can go back in and I can modify my sketches as long as I remember what that feature depends on. So I have to go in here just to kind of show you how to break this part. Let's get rid of this line. Yes, I want to delete that, and then we're going to do that, 50 millimeters. Dimension this to the origin instead. Cool, there we go. So now we have something that doesn't have a center line. Get that nice noise, best noise. Line defining the axis is not valid, so my feature is broken, it's not going to work. Hop in, edit the feature. Now see this axis of revolution is gone. So I have to go back into the sketch, edit it, add in that center line again. Around there, going up. Might as well add a construction line over to there. Oh, and it still doesn't like it. So even though I re-added that line back in, it's treating it as a new line basically that it hasn't ever seen before, so it doesn't know what to reference. Nice thing is though, I can just go in and edit the feature, and then I can just re-click that line. It's going to rebuild it for me, and now we're all happy. So now we actually have that cup all made up. Does that kind of make sense to everybody? So all those things inside that we select for the profiles, or whatever we're revolving around, whatever else. If they ever disappear, we can always go back in and add them in, change them up. We don't have to kind of start from scratch every time that a feature breaks. We just have to kind of understand what the features are depending on. In this case, the revolve depends on a central axis. Your extrusion is dependent on some profiles. So like if I remove that circle from my sketch, it's not going to be able to build a circle going upwards anymore. So let's see. Yeah. All right. So moving onwards, we can get to some of the more complex ones. Let's see. Well, I guess let's talk about cuts. So we've done extrudes to kind of make stuff. We can also do extrudes to cut away. fairly straightforward as well. Let's cut away some of this geometry on the side here. So maybe I want to make some, instead of having this be a big flat plate, I just want to make some mounting tabs instead. And then do something like that. I'm going to go ahead and add in a center line here in the middle too. It's going to make things a little bit easier. And you know what? I should probably close those off. Whoa. Cool. So I went ahead and close those off here. Can't remember if I talked about symmetrical relations in class here. I definitely talked about them in my rambly stream last week. So talk about those, and the center line. I guess I can't do that. I have to do it two at a time. So these two lines and a center line, I can make them symmetric. So whatever I do to this line here, in terms of dragging it around, it'll be the same. Also going to make these two equal. Might as well add in a center line, going from here to here. Snag that midpoint, click it on there, make coincident, make that point the midpoint of that line. Basically, I'm just adding in a bunch of dimensions or a bunch of relations to make it so that I only have to make a couple of dimensions on one of these parts. In this case, it's going to be the depth of this cutaway here, 10 millimeters, and the distance there, 10 millimeters. So you can see just with two dimensions, I made this whole part or this whole sketch work. It's kind of a little bit of review of what we were talking about last week, where we want to add in as many of those relations as possible first to make it as few dimensions as possible in our sketch, so the dimensions are actually defining what we want and not just arbitrarily kind of making our sketch look nice. So it's just, making this cutaway 10 millimeters deep, and then I want this foot to be left over to have a 10 millimeter 10 millimeter value there. Cool. So going over to a cut. Extrude cut works the same way as extrude boss. We have a blind value here, but now we have a couple of other drop downs. So we have through all and through all both. Through all is just going to go all the way through the extent of our parts. See, in this case, it really doesn't matter too much because we're not cutting into that cut at all. But let's say that this rectangle here was a bit further in, and it would have actually hit that part. This is when we want to start to use like the up to vertex or up to surface. So by clicking up to surface, it gives me this this extra place to click in the face that I'm cutting up to. Click on that. You can see it highlights it in pink to correspond to this box here, and gives us a little bit of a preview. So it's only going to cut up to that face, no further. So this is good practice if you don't know if you're going to be adding in stuff later. You usually just want to cut, only use the through all if you know that you're never going to have any geometry that cut could possibly hit. And just to kind of illustrate that, I'll still do through all. In this case, don't have anything that it's going to hit, but I'm going to go back in and change my revolve and do something wacky, like make this dimension 60 millimeters or something like that. Exit the sketch, and now I have these holes cutting through. It's less of a cup now and more of a dish. But again, this is a simple example. I know where the problem's coming from, but in the more complex part, it would be a lot tougher for me potentially to understand. Oh, hey, that feature 15 features ago is actually a through all, and I actually just want it to be an up to surface. So up to surface right there. That way, whatever I do to this cup geometry, this isn't going to cut through it. So pretty good practice there. And then same thing works for the revolve cut. You have the option to do the exact same things as we were doing with the revolve boss there. So I won't go too in depth into that. And then the only other thing that I wanted to kind of showcase here, let's see, what would be a good part here to show? Oh yeah, so I'm going to make one of these tabs here. So I'll sketch from the bottom just because it's easiest to get to. So I want to round out this corner here. I could do it with a fillet, the fillet feature itself, which we'll get to later. But just to illustrate the cut here, I am going to first convert this geometry here, convert it all. Then I'm going to place in a 3-point arc, make it tangent to that, tangent to the bottom, and tangent to there. Cool, super simple. And then I'm only going to work on one corner right now, just as an example. But we'll go ahead and trim this away. Cool. And now it doesn't have anything to reference to because I deleted the line it was tangent to. But not a big deal. I can reference that feature itself, so I don't actually have to reference the sketch geometry. So you can see that, if I were to copy this over all 4 corners, I'd have the overall profile that I'd want. And now what I want to do is cut. And what I actually want to do is cut away this outside edge here, not the inside sketch geometry that I made, but the outside. And the really cool thing is that SolidWorks can just do that within the extruded cut feature. Right now it's showing that it's going to cut all this stuff away. Just to demonstrate. So it's just going to leave this little shaving there, which is actually what I wanted to cut. So I'm going to go back in here, flip side to cut. I think this should work. Yeah, so just cut away everything except what was inside that sketch. Which is a really cool way of doing it. You don't have to, if I were, a good example, I guess, if I were to make a new part here real quick. Just do this here. Oh, 5. Cool. Real quickly extrude that out, 50, yes. And then it's probably going to be a little bit clearer with this. I want to cut away everything except the circle. So I'm left with a 50 millimeter circle on top. Extrude cut, 20 millimeters, flip side to cut. So you can see it cuts away everything outside of that 20 or that 40 millimeter, 50 millimeter circle. So really nifty feature. I actually only found out about that a few weeks ago before I was just converting all my geometry. So this saves a lot of time. Just leave what you want, or sketch what you want to have left, cut away everything else, however far you want to go. So switching back over to the other part here. So yeah, I've covered extrude cut. And then I guess we can talk about fillets. So the same geometry here we can make with a fillet itself, and not have to go through the trouble of sketching. So there's a couple of options here, different kinds of fillets: variable size, constant size, face fillet, and then this full round fillet. Full round is actually what we want, but I'll show you the other fillets here real quick. So there's our normal fillet. You pick out your radius here, 2 millimeters, for example. Then I have the option to do asymmetric. So this is kind of like an elliptical instead of a circular profile here. So just kind of illustrate, you can see that there's a 5 millimeter radius there and 2 millimeter radius going that way. Then let's see what I got. I'll probably go back to symmetric, drop that back down to 2. Profile circular, all my different profile types. Circular is probably the only one that you're ever going to use most commonly. Curvature continuous we'll kind of get to once we talk about surfacing. And then some other options: variable size fillet. Kind of start at one vertex here. This to be 5 millimeters there. V2 is going to be 2 millimeters. So you can see that at the top starts with 5, bottom comes down to 2. Kind of a nifty feature, and not very often that you'll use it. Most likely just going to be doing a constant fillet. Face fillet, pick one face, pick the other face, fillets between them instead of just picking the edge. And then this full round fillet, very nice for doing what we're trying to do here. So I'm going to start by clicking one face, then the next face. Oh, there we go. And then the last face that I want to fill it. So it's a first, middle, and last. You can also select multiple faces here if you're trying to do kind of more complex than just the one face itself. If you have a bunch of stuff or a long edge of a part with a lot of different faces coming all together, kind of pick your middle faces and then the two on either side. And it decides its own kind of radius based on the cross sections going along. The other cool thing here with the previews, you have different options: no preview, partial preview, full preview. Partial is more for if you're doing a lot of fillets kind of going all the way around a part. It'll kind of only show you a few of them just to save on processing time. Full preview is usually good just so you can see everything going on. And then, so yeah, we'll do that there. And let's see if I can actually do this. I want to see if this is possible. It is not. Okay, cool. So we can't share the faces between them. All right, so we have to do these kind of one at a time, which makes it kind of funky, but there we go. So we got that, and now I have that round geometry. So same as that over here. Just like with sketches, we can mirror stuff too. So this is another good way to do it. You just make one fillet or maybe two, mirror them over, kind of bring up, before we had a center line, now we have a face that we're going to mirror across. So in this case, the right plane, as I hover over these, they kind of show me, all right, yeah, I want to mirror over the right plane. I want to mirror my fillet. Gives me a little preview there. And then also my cut extrude that I did earlier. Let's see, which one was that? That was that one. Cool. So I can do both of them at the same time. Face for fillet or chamfer does not exist. That's cool. Cool. Let's see if this works real quick. It does not. Cool. All right. So sometimes SolidWorks is picky with stuff. Let's see if it just wants to do the fillet. Yeah. So I guess with these round fillets, it doesn't like doing that for them. Probably because the face that we used for this fillet got modified. Once we did that, and also it removed this other face over here. So what we want to do is just go through and do that fillet again. Then. So fillet, full round, 1, 2, 3. Let's see if we can do another one here. 1, 2, 3. Just letting us do. So yeah, so when you're creating this kind of fillet, it does have to be continuous. You can't make two fillets at the same time, so it's not the best tools for doing the full round. In this case, maybe that sketch tool would actually be better at kind of accomplishing the job here. Does anybody have any questions? I know it's kind of all over the place there with the fillet feature. Cool. So moving on then, I guess since I kind of brought up the mirror, let's see if I can just mirror the other cut that I made. Just the mirror cut. Cool. So that works. Yeah. In that case, probably the cut way is the best way to do it. Just create that sketch, round out your edges, and then either pattern it within the sketch or make two of them and mirror them over a central plane. And then we can also do patterns as well, if you remember. So let's say that I go back to this cut, and I want to make a linear pattern. This time, instead of automatically picking our X and Y directions, I actually have to pick like an edge or something else that defines the direction. So in this case, here's my X direction. Just want 2 in there, and then features. It's going to be that cut extrude. I don't want it to pattern this way. I want it to pattern the other way. So we'll do that. Up to reference, I think I can do it that way. No, it's going to be. Let's see here. Yeah, so I can just crank this up because I remember, 50 millimeters. Cool. So I can pattern it over. It's going to make that same exact cut, cutting away everything outside of that sketch. So not quite what we wanted. So let's see if I can go back in here and change that. So this is a geometry pattern option here. I think that's what we're going to need to do. Let me just double check. Unfortunately, no. Let's see if I can. Sorry, it's been a while since I've done linear patterns with these kinds of features, so it's going to take me a second. Yes, cuts are probably one of the features that you don't want to do patterns with, especially because they kind of cut away unnecessary geometry. We do usually want to, for patterning stuff, good idea is to pattern bodies that or in geometry that we're creating instead. So we got that. Let's see, and then we have the same one, circular patterns, mirror. It's curve and sketch-driven patterns are pretty cool. We'll get to them a little bit later on when we start talking about more advanced tools. But yeah, so we have the sketch-driven pattern one is kind of cool. I found out about fairly recently too. Let's talk about the more common ones that we're actually going to use. So shells are very common. So if you remember when we had, let's actually go ahead and just really quickly fill in this cup here. So I'm going to go back to this revolve, edit the sketch. So I don't want to do just the wall anymore. I'm going to go back to going all the way out. And go ahead and remove that construction line, move that out. So I do need to add in that solid line down the middle. There we go. Got my revolve now. Should be able to exit the sketch. Yeah, cool. So your shell basically takes away a face. Here, I'll kind of show you a preview. So it's going to take away this face, give me a thickness. Remember, we wanted like 3 millimeters. And then it's going to create a shell of the part, getting rid of these faces and just leaving that thickness. So here's what that looks like. 3 millimeters thick, but it also went down into the rest of this part here. So if we don't want to do that, we'll talk about how to do that in a little bit. I'm going to show you a section view of what it did there. So it went through everywhere in the part and kind of made a wall 3 millimeters away and cut everything else out. So that's kind of what the shell feature does. It's really handy for creating thin geometry. You just basically model, again, kind of like that glass. If you know it's going to be a constant thickness all the way around, just create the solid part, delete the face that's going to be open, creates a shell of everything else. Another way to do that, we'll kind of talk about here in a second, of creating that thin stuff is with a thin feature. We'll talk about that once we get to sweeps. So yeah, that's the shell feature. Pretty straightforward. Talk about a few more of the options here real quick. You have the option to shell outwards. So instead of keeping the outside geometry the same, this way, like if you needed for example, a container to have a certain volume, you model that volume and then you create something around it or a shell around it. So that's a good way of doing that. Showing that preview, kind of always check that. It can take a little bit of time to compute that preview sometimes. So depending on the machine you're working with, you kind of might want to be careful. And then this multi-thickness kind of gives you the option to not just have that 3 millimeters all the way through. You can make it different thicknesses throughout. Really complicated, so we won't get into it today. But let's go back to that shell. Cool. All right, so I just mentioned that we don't want to. Actually, I'll go ahead and come back to that later. We're going to talk about how to make it so that it doesn't actually go through and cut away that bottom section. Cool. So shell is a common one. Let's talk about. Really need to get into these here soon, but so yeah, just like with sketches, we got the chamfers there too. Want to cover those. Actually, we really don't have that much more. So let's go ahead and get into. Let's finish up with this example. Yeah, cool. So I'll talk a little bit about direct editing. This is a kind of toolbar that isn't by default activated, so you have to right-click somewhere up here, go to your drop-down, pull up direct editing, and then we have the option to combine and split up bodies. So let's go back to our revolve. Remember I mentioned that we don't want to merge the result necessarily, and that kind of already solved our problem. I was hoping it would throw a little bit of a fit. Basically, so if you remember when we revolved that part, Yeah, so we revolved that part all the way through. We didn't have it merged, so it's now a separate solid body. I can hide it on its own, so that's a body. And then this is a body. When I go to shell a part, it only shells one body at a time. You can't shell multiple bodies. You can see with that preview, it stops right, 3 millimeters before the bottom of this cup. So that's a really nice way of smoothing up your process. If you just want this cup specifically to sit on top of whatever this is, and kind of get shelled out all the way to there, you can go back to your revolve, make sure you don't merge it, work with it as a separate solid body, and then once I want to combine it back into one part, just click on both of those. Up here I have my different types of combines. I can add them together, so we'll create them into one. Subtract, so, we'll talk about here in a little bit with an example, and then common as well. But the added one is what we want because we have two bodies. They're touching at that face there, so I can combine them into one solid body. And then now if I section through, you can see that it's just shelled up there. So that's how we kind of solve that problem with the shells. Something you really need to watch out for with shells, because sometimes you have a 3 millimeter wall and you have a 7 millimeter thick part. Part way through, it's going to want to go through and make that hollow geometry wherever it goes in your part. So you really want to watch out for that. Always a good idea after you do a shell, go up here, do a section view, make sure that the shell actually did what you wanted it to do. Any questions about that? Pretty good? Cool. All right, let's talk about combines since we brought them up there. I'll go ahead and bring up a new part here, a little bit easier to work with. All right, so new sketch. Gonna go ahead and make, let's see, what's a good way to do this? All right, we'll start with a midpoint line here, going out. Gonna make basically a bracket here for like a shaft to go through. So kind of using the same little trick there with the line where you hover back over the endpoint to bring up the arc command, making myself a center line here so that I don't have to dimension as much. Make that coincident. You can see the yellow thing pops up, automatically adds in that relation for me. Helps to make these two symmetrical as well. So I'll click on that, and that. Add my symmetric relation. So now when I drag this one out, the other one moves too. And then, let's see here. I'll make these two concentric. All right. So I got something that looks like that. This is going to be a 15 millimeter shaft passing through here. I want the distance between these two, 10 millimeters. Then I want the distance from the bottom here. Remember shift key to get the close dimension there. I want that to be 4 millimeters. And then overall, I want this part to be no more than 65 millimeters out. Cool. So I got this here. I'm going to go ahead and extrude it out with the midplane. A little bit of review there. 20 millimeters both ways. Cool. So I have something that looks like that. And then from the top, I actually want this part to have a completely different shape. So I'm going to click on the top plane. Cool. I'm going to sketch out the shape that I want it to have. It's probably some really wacky constraints that I have. It has to like pass around some stuff. So I'm just going to do that there. Just going to have to pass around there. Go back. There's different constraints on this side. Then I'll stop that there. Drop down a construction line. Mirror those over. See, because I just selected one construction line there and everything else is normal geometry, it mirrored it all over just by default by picking that construction line. And then I will add some dimensions here. So I need 4 millimeters of clearance there, 5 millimeters on the other side. This angle is going to be 120. This included one is going to be 45. And this is going to be like a 15. So super whack geometry that I have to kind of avoid. And then I'm going to go ahead and extrude this up. So you could think that I could potentially do an extruded cut, but this is, I guess, a good chance to bring up draft angle. So you can kind of see the difference here. So drafting means that it kind of slopes inwards. You can also make it slope outwards. This is mostly a thing that happens in like injection molded parts. They have to have a draft angle on them, so when you put them in the mold, you can actually take them out. They don't just kind of stick to the walls. They actually separate from the walls as you pull them out. Also good for like carbon fiber part design and stuff like that. But let's say that I wanted to add 3 degrees of draft. I want to make this kind of way bigger than my part, so 35 millimeters, I think. Yeah, so I'm gonna not merge the result either. So I got these 2 solid bodies that are intersecting. With the combined feature, I can go ahead and make a common. So I'm gonna take both of those bodies. It'll show me a preview of what the part's gonna end up looking like. Cool, just like that. So basically by creating 2 different bodies where they intersect, so just kind of 2 different parameters. In this case, this one was kind of, hey, I need the shaft to pass through the middle. Here's what it's gonna look like from the side. This one was, my mold parameters and whatever else I needed to kind of avoid. I can just make those 2 bodies separately and then combine them together. And then you can kind of figure out what subtract is. If I wanted to go ahead and edit this, let's do subtract just for fun. Clear selections. So here's my main body. I want to subtract this from the main body. It's going to look really wacky, but you can see that I just basically cut it away. Those features are kind of more useful for working with multiple bodies in the same part. They're just kind of there. Just wanted to point them out there because we brought up how to use the kind of shell command earlier. I figured I'd touch on those really quickly. But we should really dive into these sweep features here. So sweeps and lofts and other stuff like that. For this, we need... I want those sketches gone too. That's to all. Cool. So for sweeps, lofts, and these boundaries, we need multiple sketches within the part to work with. So we'll start with a sketch on the top plane and something super simple, just a rectangle. Maybe 50 millimeters wide by 100. Hey, would you look at that? 100 exactly. Cool. So start with that, and then in order to make another sketch on a plane, in the past we've really just made sketches on these default planes and on other faces of parts. But we can actually add in our own planes wherever we want within the model with this reference geometry command within features. So within here, interesting. Oh, I need to exit the sketch first. All right, cool. So out of the sketch, make plane, axis, coordinate system, point, or a mate reference. Really all I need is a plane here. So first reference, I pick the top plane because that's what I just drew a sketch on. Now I have a couple of options. I can just make it so it's parallel to the front plane or the top plane. In this case, up here it says I need more references and constraints, so I'd have to go through and select some other stuff. Perpendicular, same thing. Coincident, right on that same plane. Really useful if you have like a face that you need to create a plane on. You just click the face, click coincident. Now you have a plane that you can do stuff with. Add an angle to it. So I can angle this plane relative to it, say 60. And then for this, I do need a second reference. So it's going to be like coincident with that line and 60 degrees to the top plane. Really, all I really want to do here is just do an offset. So I'm going to drag this up roughly to where I wanted, I think. By grabbing this blue arrow, or I'll just punch in, let's say 60. Yeah, there you go. So this actually shows me my normal. So I can flip the, there it is, flip normal. So that kind of shows me, if I start a sketch, it's going to be looking down from the top of it. Flip it so that anytime I start a sketch in that plane, I'm looking at it from the bottom. So I'll just make a plane there, make a sketch on top of it. And then we'll make a square up here. Square that is 40 millimeters by 40 millimeters. If you remember, I can make relations here so I don't have to dimension both of them. There we go. Equal. All right. So I'm going to hide this plane here just to make things a little bit clearer. I have two sketches that are separate from each other, just kind of there. And I want to make a part that kind of starts here and goes up to that sketch. So I'm going to do a loft. So here I have my profiles. Kind of gives me the option to select that one there and that one there. So it's going to try to loft between them. You can see these two green dots here. That's kind of what it's referencing off of. So ideally, you want your sketches to be to have the same amount of sketch segments, so lines, arcs, whatever else, the same amount of them, because it's going to kind of try and connect all the vertices together. So it's connecting the dots there, and making all that stuff. Make wacky stuff by dragging these points around. So it's basically mapping this corner to that one, and then carrying on. So there's one segment between each of the kind of lines that it's drawing up to there. So you can do stuff like that. Also cross it over to there. That won't work because it's going to fold over itself, but that will. So we have a couple of different options there. That's basic dragging around. Start and end constraints. If I want it to be tangent to this bottom bit here, and tangent to the top one as well, I can select that. So lofts tend to be pretty much, pretty powerful. Start to get into the realm of features that SolidWorks is interpolating in the middle. They're kind of telling it, hey, I kind of want this geometry over here, this geometry over here, and then whatever else works in between. I can give different weights to these tangencies. Like if it's really important that maybe this is like a fan duct, and I really want the the air to be coming out clean for a good long bit, and then experience a contraction and disturbance in the flow. I'll really make this, really add some weight to this handle here to really crank that up. But that's kind of your options there. And then you also have the option to do a direction vector, which instead of using the perpendicular to that face, you can actually specify a line that goes in a particular direction. And then so that's mostly what you'll encounter with lofts, is just two different sketches trying to connect the two, and then from there it's pretty straightforward. I guess let's talk about thin features. I said I was going to come back to them at some point, and this seems like a good spot to do it. Thin features. So in this case, instead of actually lofting the middle, kind of the enclosed section, you can see it's just making a thin feature, so thin wall coming off of the outside edge of that sketch. And kind of gives me the option to do one direction, mid-plane, or two direction. So with one direction, you can see it's starting at the sketch and going out. Or if I want to flip it, it can go in. It's going out by 1 millimeter. You can also grow that out. So start with just one. If I do a mid-plane, centers the sketch around that thin feature. And if I do two direction, I have the option to control how far it goes each way. So I can make it really thick on the outside and just a little bit on the inside, whatever else. But thin features can be pretty powerful as well. So again, thinking about if this was a fan duct and I know how big my fan is and it needs this amount of area to blow through, I can just model that circle, and then I can make a thin feature going on the outside of it so that I'm not kind of encroaching on the flow area inside. And then, so that's basically thin features. Instead of creating, if we kind of think back to shells, instead of creating this solid body and then trying to shell it out as well, we can just create the thin feature right away. And be pretty powerful in a couple of situations there. So let's go ahead and make that, and kind of spin it around just so we can see what we're working with. And like I said, usually when you make your lofts, you want to have the same amount of sketch segments in both sketches. So rectangle to rectangle, circle to circle, polygon to polygon of same size. But what if we don't? Let's just edit this sketch here, get rid of everything, just all, make a circle. Dimension that out to 45 millimeters. And then we're going to try to make a loft. Cool. That profile. See, it still works. What SolidWorks does at this point is it basically cuts apart your sketch into segments on its own. So it starts to guess at kind of where you'd want to split it up. In this case, because we have a rectangle here, it's taking the perimeter of the rectangle and basically normalizing how long this edge is with respect to the perimeter, making that same kind of scale change here with the perimeter of the circle. So this arc length proportional to the circumference of the circle is the same as this line length proportional to the perimeter of that. And then I can also drag this around. If I keep dragging it, it's going to keep spiraling it. And kind of, it's parsing this this loft geometry or this circle up here into separate arc segments. And you can notice that as I drag this around, it's very hard for me to figure out kind of where my points are. I don't have finite control of where exactly this is going to be. I can just drag it around arbitrarily. It's going to float around, but I can't fix it to a specific point because this is just one sketch segment. I want to have multiple sketch segments within my part. So to do that, I could go back into the sketch, edit it. Pretty sure if I can just add a point in here. Let's see. I'm actually going to go ahead and add 4 points. That one should be there. Cool. I'm going to add in some construction geometry so I can define the locations of these points. Cool. This line's going to be vertical. Same with this one. Both of these are going to be horizontal. I'm pretty sure I can. Let's see. Cool. So a little bit more advanced tool here. Split entities. So I'm just going to click on this circle. And it's going to start to, hold on. That's how I should do it. All right, let me back out of here real quick. All right, so going back into that split entities tool, notice up here, I have like a command search that I can go through. And the way that I brought that up, just to give you guys a tool tip, by clicking S, it brings up my shortcut, automatically goes to a command tool as well. So split entities, we'll just start typing after hitting S. There we go. I'm just going to plot in those points where I want to split this circle up into a bunch of different entities or a bunch of different sketch segments. Cool. So that way I now have all these points. You can see that I'm hovering over this arc here. It's its own thing. That's its own thing. That's its own thing as well. And then probably the best way to do this and to actually define them all is to go ahead and create a rectangle. Make those points merge. Same with those. Merge those points and merge those points. Cool. So that makes it that now I have this sketch or this rectangle. Click on all 4 sides of the rectangle to make them construction geometry because I don't actually want to use them for creating anything. And that way I can dimension how much spacing I want between all those segments. So now going back into that loft, there to there, you can see that now I have these discrete points I can snap to kind of orient my loft feature. All right. Cool. Just like that. Again, like this is a great example of where you'd want to use like a fan duct. You have your fan there, and then going out to kind of a more rectangular exit or a vent, or this could be any shape. But for fans, usually fans are circular, so we want to have a circular profile there. Let's take a quick break because we are at about the 1 hour mark. I'm going to go grab some water real quick, and then we'll continue onwards. If you guys needed to take a break, get up and stretch, welcome to do that as well. I'll be back in about All right, let's get back to it. Next feature on the list is going to be sweeps. Sweeps are kind of cool in that you're basically taking a similar cross section and kind of dragging it along a path. So we'll start off kind of with a sketch here on our top plane. Make a circle. That's usually, or that's one of the common shapes that we're going to sweep. We'll talk about some tricks with circles specifically here in a little bit. But start with a 20 millimeter diameter circle. And then we want to sweep this along a path. So we need two different sketches for the sweep. We need a profile that's being swept, and then we need the path that's going across. So in this case, we'll draw a profile on the front plane, make a sketch here, and you'll notice I'm going to do something that I'm not going to make this profile really make sense to start. I'm just going to kind of draw it out here, and then maybe I'll take an elbow. Maybe we're making like a PVC elbow here or something like that. So these two are going to be equal. Have some kind of length here, 25 millimeters. This radius needs to be 15. And then what I want to do is I actually want to click on this endpoint and circle there, hopefully. Select other. So I want to actually click on the origin of that sketch. Click on that. I guess that should still work. Yeah, so we'll just make coincident. So basically, in this case, since that sketch is centered at the origin there, I can just make this coincident to the origin. The key thing here is that you want your path to intersect your sketch or your profile sketch. You don't want it to be kind of floating around in midair as I was originally designing it there. You want it to intersect there. So as we go and start setting up this sweep, there we go, sketch profile. There's our path. Automatically select that as our path, and then we'll select this as our profile. And you can see just dragging that circle all the way across here. Can do a couple things with our profile orientation. That probably won't work. But yeah, so right now, this circle is just following the path and staying normal. So you can see at each of these endpoints, the circle is staying normal to the path. And then we can specify a twist. It's going to be kind of hard to see with this one here or with a circular profile, but we can actually make it twist all the way along, or we can try to keep it the same. Showing us our preview there as well. You can also merge tangent faces. So you can see that as I click that, it gets rid of those intermediate edges. And I guess I'll actually make this a part here to show you. So I have these faces there. They're all tangent to each other. If I were to click merge tangent faces, it would just make one big smooth face instead. There's different times that you want to use each of these. Kind of go into depth. It really just depends on the kind of part that you're designing, what you're designing it for, if it's going to be the smooth aesthetic piece, or if you're actually going to need to reference off of the start of that elbow at any point. So kind of use your judgment when you want to merge them together. Usually if you don't have a reason to merge those faces, it's best to just leave them in, because you might need to use them at a later date. Start and end tangency, kind of start tangent to the profile here, and tangent as well. We can specify that to be the case. Sometimes with more complex paths, your profiles start to get really wacky. And then what was the other thing? So with this, we can also do a thin feature, if I remember right. Start and end, orientation. Or no, I guess we cannot. Thought we could. Hold on, let me delete this feature again real quick, because I'm pretty sure we can do a thin feature. Yeah, so we can generate a thin feature here. Once we actually generate the feature itself, we can't go back in and edit it to make it a thin feature, which is kind of wacky. I'd expect SolidWorks to be able to do that. All right, so thin feature. Remember, same thing that we talked about before. You're creating that loft and then kind of shelling at the same or the sweep and shelling at the same time. Go outside or inside of the profile. Specify a thickness, like 2 millimeters, for example. And then your start and end tendency is still there. All your options. Cool. And then in this case, if we're trying to create a certain flow rate through here, we want a certain cross-sectional area, we just draw that area, and then we make the pipe on the outside of it. So that's what we do there. We can, so with sweeps, you're fairly limited, compared to the lofts that we were talking about earlier. You have one path and you have one profile, and that's really all it boils down to. But we can do a couple of other things with it. So let's go ahead and delete this. Yes. I'm going to go ahead and make another sketch on the front plane. And this one is going to be a little bit different. So it's going to start, again, kind of somewhere here. So bend up. And then it's not going to end up being... So basically what I'm trying to do is make it a nozzle on the end here instead of a constant cross-section. This brings up a new kind of relation to that we can do that I was trying to bring up earlier, but I realized that because we were centering around the origin there that it wouldn't do it. So here I selected the point, I selected my earlier sketch path, and now I have a pierce relation that I can add. So what this does is that point is always going to lie along the intersection of this sketch with our plane. So it's not just coincident, it's actually piercing through. So if you can think about that arc kind of coming through your sketch plane, poking a hole in it, that point is always going to be where that hole is poked. And then, if you remember, I can do relations between these, make them equal. I can make this radius, both of those have the same point that they go about. And then these two, actually here I'm going to put in some construction geometry to make this a little bit more obvious that this end is going to end up being vertical. And then I want to specify an angle, or actually I want to specify the outlet of my nozzle. So I'm going to go ahead and bring this geometry in, convert entities, make a construction geometry so I can do that neat little trick we were talking about earlier, where I make the diameter of my nozzle 10 millimeters. And I can actually specify the diameter instead of just the radius. Cool. So let's go back and create another loft, or a sweep, sorry. So we'll start with our profile, do our path, and then we have this option for guide curves. And we had this option in Lofts as well. I just didn't cover it there. We'll kind of go back in and show you how it works with Lofts as well. But I can select this curve here, hopefully. And let's see. Options, profile orientation. Interesting. So I'm going to have to look into that because I think it doesn't actually like changing the cross section of that. So this is probably a good one for a loft. Talk about that here in a little bit. Actually, let's go ahead and do that. So let's delete this feature, go back through and create a loft to accomplish the same goal. I'm going to have to review my notes on sweeps. But this kind of gives us a good opportunity to revisit different ways of creating planes. So if you remember, we wanted to create, so basically we want to create another sketch on the end here. So we'll do, I want to create a plane that's normal to that, perpendicular, and it's coincident to this endpoint here. There we go. Cool. So you can see I just created a plane on the edge of a sketch line. Super handy. Just kind of bring that kind of stuff in. All right, create a sketch on there. Make a circle. Center it around that origin. Going out. And then what I want to do is to actually make this guide curve here. So what I'm trying to do is kind of guide the path along there. I want to make that guide curve pierce the sketch and not the other way around. So what I'm going to do is I'm going to exit out of my sketch. I'm going to go ahead and drag both the plane and the sketch before that guide curve one. It just wants me to do them one at a time. So there we go. So I'll drag that above there. And then let's go ahead and edit the sketch. Create this to be 10 millimeters. Cool. Exit the sketch. Go back in, edit my guide curve. Instead of making this dimension 10 millimeters here, I'm going to go ahead and make another pierce relation. So click, click, pierce. There we go. All right, so let's talk about this with lofts then. So we have our profile. So we got this one here and that one that we're trying to loft between. See, it's just trying to go straight across. Add in this guide curve here. And that kind of starts to give us the shape that we want. Add in another guide curve. Centerline parameters, that's right. That's where we can do it. So center line is going to be right here. You can see it kind of looks a little bit weird. It's really weird. I haven't done this in a long time. All right, normal to profile on both. Kind of starting to get to where we want, but it's still really finicky. Guide curve influence. Trying to see. All right, so it looks like I'm going to have to go and revisit my notes on lofts, which is a shame because these can be really powerful. Basically, what I'm trying to do, as you hopefully gathered, is to make a straight pipe go here, curve, and then funnel down into a nozzle. Boundary might be the option to go with as well. Let's try that out. So these are all kind of, so loft, sweep, and boundary are both ways of kind of taking profiles. Yeah, I really have to go through and revisit those. But they're all ways of creating either constant cross-section or similar cross-section with guides that kind of point you in the right direction, where you're creating kind of stuff that navigates its way. Like piping, ducting, that kind of stuff is usually good applications for those. I haven't done too much of that myself, but one thing that I do want to touch on really quickly, I was saying that circles are fairly special with sweeps and that we do them a lot. So SolidWorks actually added in a section here to specifically do circular profiles. So all you need is a path sketch. We don't need any of this other stuff. We can just click the path that we want to have a circle or a circular profile go around, specify our diameter here, 5 millimeters, and also make it a thin feature. So super simple there. I'm just making a 5 millimeter tube on the inside that's 1 millimeter thick, going all the way through. All I needed was that path, so it's super nice. And then down here, I guess I'll quickly touch on curvature display. This kind of gives you some preview of what your part is going to look like, because sometimes you have these really wacky curvatures that start to happen with your paths. This one's pretty straightforward. It's just a line, curve, and a line, an arc, and another line. But you have a couple of different options for seeing what your surface curvature is like. So there's zebra stripes. We'll kind of touch on these more when we get to surfacing. But I just wanted to show you that they're here. The curvature combs are a little bit of a mess, but we'll kind of get rid of those. Direction 2. Yeah, so that kind of shows you just the localized curvature of your path all the way along as you're going through. So yeah, so I think that's all that I had to cover for those features. They have the same options for sweeps as well, or for cuts as we do for actually building stuff up. We can sweep a cut through, we can loft a cut, we can do a boundary cut as well, fill it, or I guess, yeah, so we can do those 3 things there. I guess let me bring in another part here, show you. I think I have a way of doing a boss here. So let's do a sketch, top plane, same thing we were kind of doing before with that fan duct. Cool. Let's make another sketch. I'm going to make a plane off of the top plane. Sorry, not front plane. Top plane, offset 100 millimeters. 100 millimeters. Make a sketch on it of a circle. Dimension that circle. Be 120. Fairly common fan size. Cool. And then we're going to loft between, or we're going to make a guide curve here. So I'm going to sketch on the front plane. Going to do something. Looks like. Let me get rid of this plane so I don't have to look at it. hide it. Cool. Back to my sketch. This normal 2 button right here is really useful for kind of going back to, you know, as you're kind of working with multiple sketches, you can hop back in and take a look at stuff. And then I want to make this a really sharp transition in my boundary, basically. So I'm going to pierce that there, and pierce that there. And then this is going to be like a 50 millimeter extension there that's going to go straight. Cool. So I think this should work. Exit the sketch. Make a loft here, there. Give it a guide curve. There we go. So you can kind of see adding in this curve here. It's only working on one side of the part. It's kind of trying to do something else and interpolate on the other side. So what I can do is I can make another guide on the other side that does exactly the same thing. So let me go ahead and do that real quick. So make another sketch on the front plane. This time I'm just going to do a center line here to there. Mirror these over and call it a day. Oh, I used to mirror. Actually bring these in. There we go. Actually, I should make those 2 construction. Cool. All right. So again, loft base or lofted boss, there to there, guide curves. There's one and another. Cool. So now I kind of have what I was looking for. I have the straight section coming out and then an angled part going down. So that's kind of took a little bit longer than I wanted to, but that's kind of an example of with your lofts, you have a little bit more control over how you're creating this part versus your sweep where you have just that constant cross section. And then with boundary, you actually have even more control, which I'll kind of study up a little bit, and we'll come back next week and I'll show you guys a couple of better examples to illustrate the power or the kind of how boundary, boss, and base works. Cool. So we'll go ahead and do that. Now we have our little fan duct there. Let's toss in some fillets here just for a good measure. So these are our kind of normal fillets that we're most commonly going to be using. Just a constant size here. I can go ahead and make these a little bit bigger to blend stuff in. You're going to start to see here that the part is actually fairly close to tangent at those points. So let's see if this actually builds, and it does. Cool. And you can see that because of the discontinuity along our faces, you know, even though these share the same radius, it's going to be a different kind of part or a different shape fillet there. So not necessarily the cleanest design. Like I said, we'd want to probably use a boundary if we wanted to do something a little bit closer to that. Or we can go in and actually add that fillet into our guide curve sketch. Cool. Let's see. Just trying to figure out if there's anything I missed. Linear pattern works the same way with features and bodies as it does with you know, in sketches. You have your directions there, the angle between your directions, how far apart they are, dimensioning everything. You can copy features, you can copy faces, you can also copy solid bodies. So let's just do that just for fun of it. I'm going to move this over that far, 210 millimeters. Now we have 2 of those bodies within the part. And I can make multiple of them. Probably wouldn't need to in this case, but maybe I had, you know, kind of an arrangement of 4 fans, and I wanted to make, you know, 4 individual ducts, and then maybe connect them together with a plate on this side. So that's potentially one application of patterning. You have several the same geometry, and then you want to connect all that geometry with something common. Same thing with circular patterns. You know, we already covered mirrors earlier on. Drafts, kind of briefly touch those. Those are included within your extrusions. So you can, you know, just add those in if you're creating parts for, you know, carbon fiber or anything that's going to have a mold for it. Really want to pay attention to drafts and make sure that you're adding those in so that your part comes out of the mold and doesn't get stuck in it, like we did with the steering wheel last year. And I think other than that, we're fairly set for today. And sorry for being all over the place. Haven't had too much sleep. We're going to talk about Hole Wizard later on. This is going to be one of the things that we really want to use a lot. And we'll kind of talk about that in our, I think it's our 7th session or second to last session. So we'll talk about that there. But for the most part, you should be able to start creating parts. These extrusions and revolves are basically going to be the bread and butter of your modeling. You're most likely going to have constant cross-section stuff that you're coming out with, or a revolved cross-section. These interpolated lofts and stuff like that are a little bit rare. Usually it'll just be kind of like this situation where we have a fan duct or something else coming through, or two different faces that are critical, and then whatever's in between, it just needs to connect the two of them together. Yeah. Any questions before we call it a day? So I can go take a nap. No? Cool. All right. So next week we're going to be, I'm going to bring back loft sweeps and boundaries once I've reviewed my notes on those. And then we'll go into assemblies and drawings. So those next week is probably going to be a little bit shorter, maybe about an hour 15, instead of kind of the fairly regular hour and a half that we've been doing so far. Yeah, thanks guys for coming. I'll hopefully see you next week.